Yesterday we have seen monohybrid cross. What is monohybrid cross? Crossing with single trait or crossing with a pair of contrasting characters is called monohybrid cross. So the monohybrid cross phenotypic ratio 3:1, genotypic ratio 1:2:1. So now we are going to see about dihybrid cross. So dihybrid crossing with two pairs of contrasting characters, crossing between two pure breeding varieties of plants that differ from each other in two pairs of contrasting characters. Two pairs of contrasting characters. That's why crossing with two pairs of contrasting characters or two characters is called dihybrid cross. So Mendel selected pure breeding varieties as parents. Pure breeding varieties in the sense, a pure breed variety is one, pure breed is one, which can able to give rise to same kind of offsprings for many number of generations on self-pollination and self-fertilization. Now you just see the dihybrid. Mendel selected pure breeding round seeds and yellow cotyledonous variety. We plant with round seeds and yellow cotyledonous variety. Like that, pure breed wrinkled seeds and green cotyledon variety. These the parents are pure breeds. The parents are pure breeds. Pure breeds in the sense which can able to produce same kind of offsprings for many number of generations on self-pollination and self-fertilization. You just see that here, pure breeds always produce only one type of gametes, even in monohybrid cross. You just see that here, capital T, two gametes in the sense they are same. Small t. Two gametes of course, but they are all same. That's why one type of gamete. Pure breeds produce only one type of gametes in monohybrid cross. As well as in dihybrid cross also, pure breeds produce only one type of gametes. So whatever be the number you give, another R, capital Y, small r, small y. So only one type only. So pure breeds always produce only one type of gametes. So Mendel selected pure breeding pea plant with round seeds and yellow cotyledonous variety, and he made a cross with which variety? Wrinkled seeds and green cotyledonous variety. All the offsprings in the F1 generation were round yellow. Why round yellow? Round seeds dominant over wrinkled seeds. Then yellow cotyledons dominant over green cotyledons. That's why you get dominant character. So in the dominant character, what happened here? The F1 dihybrid. The F1 is a dihybrid. F1 dihybrid should produce four kinds of gametes. F1 dihybrid should produce four kinds of gametes in accordance with the law of independent assortment. Whereas monohybrid produces two types of gametes. Monohybrid produces two types of gametes. Dihybrid produces four types of gametes. So here monohybrid produces two types of gametes because of law of segregation. Law of segregation. When a pair of alleles are brought together in a hybrid union, the members of the allele pair remain together without mixing with each other but separate at the time of formation of gametes. That's what law of segregation. But here, the F1 dihybrid should produce four types of gametes in accordance with the law of independent assortment. In accordance with the law of independent assortment. What is law of independent assortment? When two pairs of contrasting traits, are combined. When two pairs of traits are combined in a hybrid, dihybrid, segregation of one pair of character is independent of other pair of character. So the inheritance of genes of each pair in a dihybrid, of course character, inheritance of genes of each pair in a dihybrid during gamete formation is independent of each other. You just see that here in parent, capital R moves with capital Y, small r moves with small y. Whereas in a dihybrid, capital R moves with capital Y, small r moves with small y, but also with the recessive one and dominant. Capital R not only moves with capital Y, capital R also moves with small y. Small r not only moves with small y but also with capital Y. So that's why this one called independent assortment. Why it is possible independent assortment? Genes located on different chromosomes, one gene per chromosome. You just see that here, only one gene is present, capital R here, small r here in this chromosome. Next chromosome, capital Y, another one, small y. Like that, one gene per chromosome. Then only which law is possible? Independent assortment is possible. Because of independent assortment, what happened here? The F1 dihybrid should produce four types of gametes. Which are the four types of gametes? Capital R, capital Y, small r, capital Y, small r, small y. You just see that here, The capital R not only moves with capital Y but also with small y. And then small r not only moves with small y but also with capital Y. That's why you get four types of gametes. This is what called independent assortment. Because of independent assortment, the F1 hybrid should produce four kinds of gametes. Of course, when F1 hybrids are self-pollinated, actually self-pollination in the sense what it is, here capital R, small r, capital Y, small y into capital R, small r, capital Y, small y. So this is what selfing. When the F1 dihybrids were self-pollinated, the offsprings produced in the F2 generation, the ratio of 9:3:3:1. So how the combinations are here? You just see that here four types of gametes: male F1 hybrid, then female one. Male gamete, female gamete. Capital R, and then this gamete fused with this one, like that. Fused with this one with this one with this. So like that you get four types of combinations. Then here, so like that, this one fused with this. These are again this type of offspring. So like that, this is what 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 offsprings around yellow. Then 3 offsprings round green. 1, 2, 3 round green. Then 3 offsprings wrinkled yellow. 1, 2, 3 wrinkled yellow. Wrinkled yellow. And the last one, wrinkled green. So this is what? 3 kinds of, actually 4 types. The offsprings produced in the F2 generation, the ratio of 9:3:3:1. 9 round yellow, 3 round green, 3 wrinkled yellow, 3 wrinkled green. Here, round yellow and wrinkled green are the parental combinations. Round green and wrinkled yellow are recombinations. Why you get recombinations? Recombinations arise due to law of independent assortment. Due to law of independent assortment. In the F1, what happened here? When the F1 hybrids were self-pollinated, offsprings produced in the F2 generation, the ratio of 9:3:3:1. 9 round yellow, 3 round green, 3 wrinkled yellow, 1 wrinkled green. Here round yellow, wrinkled green are parental combinations. Then round green and wrinkled yellow are recombinations. Why is it recombinations? Because of law of independent assortment. So what is law of independent assortment? The inheritance of genes of each pair in a dihybrid. The inheritance of genes of each pair in a dihybrid, 2 pairs of genes. One pair, another pair. One pair, another pair. The inheritance of genes of each pair in a dihybrid during gamete formation is independent of each other. So that's what here. Actually dominant character not only moves with the dominant character but also with the recessive character. Recessive character gene not only moves with the recessive gene but also with dominant gene. So that's what independent assortment. Why independent assortment is possible? Independent assortment is possible only during meiosis. During meiosis they may be arranged in any way, any fashion. How they are arranged in the sense, so in meiosis they are arranged in the sense you get capital R, capital Y, capital R, small y. Here capital R, capital Y type of gamete, small r, small y type of gamete. And then again, in another combination, if the chromosomes are in this fashion, if the the chromosomes are arranged in the other way, if the chromosomes are arranged in this way, you get capital R, small r, capital Y. So these were genes that are located on the different chromosomes. One gene per chromosome. Such genes can assert independently. So law of independent assertment. So when two pairs of traits are combined in a dihybrid, segregation of one pair of character is independent of other pair of characters. Genes, that's what genes that are located in different homologous chromosomes, of course homologous chromosomes, different homologous chromosomes. This is what one homologous pair, another homologous pair. So genes located on different homologous chromosomes can assert independently during meiosis. So that's what law of independent assertment. Because of law of independent assertment, dihybrid should produce 4 kinds of gametes. Okay. So this is what dihybrid cross. Then how wrinkled seeds are produced. Molecular explanation for the formation of round and wrinkled seeds. Before you going into that one, again, what it is test cross? Yesterday we have seen the test cross. What is back cross? Crossing of F1 hybrid crossing of F1 hybrid back to any one of its parents. That's what called back cross. Crossing of F1 hybrid back to any one of its parents is called back cross. So like that here, there are 2 types of back cross: dominant back cross, recessive back cross. Dominant back cross phenotype, all the organisms are phenotypically similar, so you cannot differentiate the offsprings. Whereas in recessive back cross, monohybrid recessive back cross, the offsprings can be differentiated both genotypically and phenotypically. That's why you can differentiate. So it helps to know about the purity of the parents. That's why purity of the parents, and then genes present in the what kind of genes are present. It helps to know about the purity of the parents. That's why it is also called test cross. Recessive back cross is also called test cross. The ratio of recessive back cross 1:1. Phenotypic ratio 1:1. Genotypic ratio 1:1. So now you just see that here, like that you get dihybrid back cross. Dihybrid test cross. Dihybrid test cross. Dihybrid cross. Dihybrid test cross. So what is dihybrid test cross in a sense? Actually, recessive back cross only. It's P parents, round seeds, yellow cotyledons, wrinkled seeds, green cotyledons. Then F1 dihybrid, round seeds and yellow cotyledons. So F1 generation, round and yellow. Round yellow. Round yellow, capital R, small r, capital Y, small y. What it is a dihybrid, crossing of F1 dihybrid back to its recessive parent, wrinkled green. Crossing of F1 dihybrid back to its recessive parent. That's what called dihybrid test cross. So round yellow, capital R, small r, capital Y, small y. So very important for the examination point of view. F1 dihybrid, round seeds and yellow cotyledons, wrinkled seeds and green cotyledons. Here genotype small r, small y, small y. And then kinds of gametes, capital R, capital Y. Capital R, small y, small r, capital Y, small r, small y. So F1 dihybrid should produce how many types of gametes? 4 types of gametes. Whereas wrinkled green recessive parent produces only one type of gamete, small r, small y. It's a pure breed. Now, checkerboard method, Punnett score method. Checkerboard is also checkerboard method, Punnett score, commonly called Punnett score method. Male gamete, female gamete. This one are male gametes. This one female gamete. Small r, small y. Capital R, capital Y. Capital R, small y. Small r, capital Y. Small r, small y. Then this one fused with this. Capital R, capital Y, small y. Capital R, small y, small y. Small r, capital Y, small y, small r, small y, small y. Now, this knowledge is very important for the next one, linkage and crossing, or for which it's a basic thing for the next lesson. Okay, that's why it's a very important one. You just see that here, phenotypic ratio. Phenotypic ratio 1, round yellow. Phenotypic ratio round A1, round yellow. This one round yellow is to 1, round green. Round green is to 1, wrinkled yellow is to 1, wrinkled green. Wrinkled green. Phenotypic ratio. Genotypic ratio. Same thing as this. 1, capital R, small r, capital Y, small y. It's to 1, capital R, small y, small y. It's to 1, small r, capital Y, small y. Is to 1, small r, small y, small y. Now you just see that here the ratio 1:1:1:1, 4:1. So proving that the 4 types of gametes are producing equal numbers. Why the 4 types of gametes are producing equal numbers? Because of law of independent assortment. So it helps know about dihybrid recessive backcross. Helps know about the purity of the parent. That's why it helps to verify which law. Dihybrid test cross used to verify law of independent assortment. The F1 dihybrid should produce 4 kinds of gametes in equal numbers. That's why you get 1:1:1 like that. So remember this. It's a very important dihybrid test cross. Very important. Very important. Okay. Now, molecular basis for the formation of round seeds and wrinkled seeds.